NASA's nuclear rocket will take us to Mars quicker than we thought. By 2035, NASA wants to land humans on Mars. But reaching the red planet, on average around 140 million miles away, will be a mammoth feat. Colder than Antarctica and with little to no oxygen, Mars is a hostile environment, so the longer it takes astronauts to get there and the longer they stay, the more they are at risk. That's why scientists are looking at ways to reduce trip time. To solve this issue, Seattle-based company UltraSafe Nuclear Technologies has proposed a solution: a nuclear thermal propulsion engine that could get humans from Earth to Mars in just 3 months. So, is it really possible to rely on nuclear technology to get us to Mars? Let's find out. Welcome to Space World. In today's video, we are going to talk about the nuclear rockets being built by NASA that will take us to Mars quicker than we thought. So if you want to know more about it, then stay with us until the end of the video. Did any of us think that the pathway to humans on Mars lies through the atom? None of us did, but it's sure to become a reality soon. Far from Earth, whether in the void or on another world, power is life. A steady, strong flow of electricity is as crucial for operating computers and engines as it is for assuring access to corporeal necessities such as light and heat, breathable air and potable water, and preparation or even growth of food. And one of the most potent and reliable ways to get all those vital kilowatts is via nuclear fission. Something aspiring astronauts realized long before anyone ever reached space or delivered nuclear weapons for that matter. Yet more than 60 years into the space age, nuclear fission for spaceflight remains mostly a dream. Now, however, as NASA pursues its Apollo-esque Artemis program to build a crewed lunar outpost with an eye toward eventual human landings on Mars, a rare alignment of technology, funding, and political will is on the verge of making spaceborne nuclear reactors a routine reality. In 2020, the White House gave NASA a 10-year deadline to deliver a 10-kilowatt nuclear power system to the surface of the Moon. The project is now a top priority of the agency's Space Technology Mission Directorate. And in July 2021, congressional appropriators earmarked $110 million for NASA to advance development of a new nuclear rocket suitable for sending cargo and crew on interplanetary voyages. Now, with the advancement of technology and ideas of building nuclear rockets, Michael Eads, Director of Engineering at USNC Tech, says that nuclear-powered rockets would be more powerful and twice as efficient as the chemical engines used today, meaning they could travel further and faster while burning less fuel. Nuclear technology will expand humanity's reach beyond low Earth orbit and into deep space, he stated. As well as enabling human space travel, it could open up space for galactic business opportunities, he says. So how can nuclear rockets travel faster than traditional rockets? Most rockets today are powered by chemical engines. These could get you to Mars, but it would take a long time, at least 3 years for a round trip, says Jeff Sheehy, Chief Engineer of NASA's Space Technology Mission Directorate. NASA wants to get there faster to minimize the crew's time in outer space, he says. This would reduce their exposure to space radiation, which can cause health problems, including radiation sickness, increased lifetime risk of cancer, central nervous system effects, and degenerative diseases. It would also decrease the overall risk of the mission. The longer you're out there, the more time there is for stuff to go wrong, Jeff adds. That's why the space agency is looking to develop nuclear-powered rockets. An NTP system uses a nuclear reactor to generate heat from a uranium fuel. That thermal energy heats a liquid propellant, usually liquid hydrogen, which expands into a gas and is shot out the back end, producing thrust. NTP rockets produce twice the thrust per unit of propellant than a chemical system, which is like saying it does double the miles per gallon. This means the technology could get astronauts to Mars and back in less than 2 years. However, one of the main challenges for building an NTP engine is finding a uranium fuel that can withstand the blistering temperatures inside a nuclear thermal engine. USNC Tech aims to have solved this problem by developing a fuel that can operate in temperatures up to 2,700 degrees Kelvin. Along with other companies developing similar technology, USNC Tech has presented its development to NASA. Now, is the nuclear option safe? Well, according to the study conducted, shorter missions would limit the crew's exposure to space radiation. But there is still concern about the radiation emitted from the nuclear reactor inside the spacecraft. This would be mitigated through the rocket's design, Eads explains. The liquid propellants stored between the engine and the crew area block out radioactive particles, acting as a tremendously good radiation shield, he says. The distance between the crew and reactor also provides a buffer, and any NTP design would place the living quarters at the other end of the rocket to the reactor. Moreover, to protect people on the ground, NTP spacecraft would not lift off directly from Earth. Instead, a regular chemical rocket would hoist it into orbit, and only then would it fire up its nuclear reactor. Once in orbit, it could do little harm, as blasts and thermal radiation cannot move through a vacuum. So, if disaster struck and the rocket's reactor broke up, the pieces would not land on Earth or on any other planet for tens of thousands of years. By that time, the radioactive substance would have naturally decayed to the point where it wasn't hazardous anymore. Now, although USNC Tech's current goal for a one-way trip is 5 to 9 months, nuclear-powered technology has the potential to cut journeys from Earth to Mars to just 90 days. These faster journey times could open up a wealth of opportunities. Therefore, USNC Tech is hoping to develop its technology for government agencies like NASA and the Department of Defense, and for the commercial space market. The company says its concept could help to power space tourism and rapid orbital logistics services, such as transporting satellites or delivering spacecraft capable of repairing satellites out in space. Scientists also agree that nuclear-powered rockets will be key to opening up the solar system, but cautions that it could be at least 2 decades before they are used widely. In addition, numerous demonstrations and tests would need to be carried out before a crew is sent to Mars in an NTP rocket. Nobody's ever flown nuclear propulsion yet, Sheehy says. I think it's going to have to be flown a few times before somebody sells tickets. However, it's not the first time NASA has flirted with nuclear rockets. In the 1960s, the government developed several nuclear reactor engines that produced propulsion much more efficiently than conventional chemical rocket engines. Adding to this, NASA started scheming about a permanent lunar base and a first crewed mission to Mars by the early 80s. Sound familiar? But as with so many NASA projects, nuclear rocket engines soon fell out of favor and the office in charge of them shut down. Now, for the last decade, Phil Emmerich, who is at the center of NASA's nuclear program, and a team of engineers have been simulating the extreme conditions inside a nuclear rocket engine at the Marshall Space Flight Center. Instead of triggering a fission reaction, they use large amounts of electricity, enough to meet the power needs of several hundred average American homes, to heat the fuel cell several thousand degrees. Think of it as a big microwave oven, Emmerich says. Called NTREES for Nuclear Thermal Rocket Element Environmental Simulator, this project has been the backbone of NASA's quiet return to nuclear propulsion. Emmerich and his team used the simulator's large chamber to study how materials react to extreme heat without incurring the costs or dangers of a full nuclear engine, as NASA did in the 60s. A few years after NTREES came online, NASA folded it into a larger program to study how a nuclear engine could be integrated with the Space Launch System, the agency's next-generation heavy lift launch rocket. The early programs laid the foundation for a nuclear rocket engine. NASA's next step was to develop the hardware needed to take the engine from theory to reality. In 2017, NASA awarded BWX Technologies a 3-year, $19 million contract to develop the fuel and reactor components necessary for a nuclear engine. The following year, Congress earmarked $100 million in NASA's budget for the development of nuclear propulsion technologies. And this year, they got another boost when Congress added another $125 million for nuclear propulsion. But before a nuclear rocket engine gets its first flight, NASA needs to overhaul its regulations for launching nuclear materials. In August, the White House issued a memo that tasked NASA with developing safety protocols for operating nuclear reactors in space. Once they're adopted by NASA, the stage will be set for the first flight of a nuclear engine as soon as 2024. This coincides with Trump's deadline to return American astronauts to the moon. Maybe this time they'll be hitching a ride on a nuclear rocket. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. And don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.